Yep. Did it start? Oh, yes, it did. Okay.
Yes.
I'm used to it announcing when it starts recording, but it doesn't do that on mine, I guess.
Great. Hello, everyone. We're recording and all set to go, right? Yes. So, welcome to the third workshop. This is part two of an introduction to programming in R. This is part of a very long workshop and hackathon series. We had part one on Monday of R, and then part two today. We're going to have the version control basic workshop on September 24th, and then the data visualization workshop on October 10th. All of these workshops are meant to lead up towards our 2-day hackathon, which is going to be on November 1st and 2nd. If you need any more details, or if you haven't filled out our application form for the hackathon specifically, feel free to visit our website, biodatasage.com/fair. Cool. So, very quick recap of what we did on Monday. We first did a tour of our studio. By we, I mean Alyssa. Alyssa showed you what our notebooks were, and we used an R notebook together. She then introduced us to the YBRS dataset from CDC, and we explored that with basic R commands. We understood R packages and what loading in a library looked like. We also imported data directly from CDC as well. And then we looked at different type of data classes and how to manipulate data using R functions, and then eventually write the data set that we were working with throughout the entire class. So today we get to explore Tidyverse a little more and really dig deep into some functions and do some more data manipulation. So if you haven't opened your Posit Cloud platform account already, you want to do that. And I can drop the link to on the chat to access the cloud space again if you need it. Once you're in, can you raise your hand so that I know who's in the project space, and if we need to wait for anyone else? Almost have everyone. Um, if anyone needs help with setting up your Posit account, or you are not able to find the project that you started on Monday, please let Alyssa know in the chat and she can help you work through it. Cool. So if you weren't here on Monday, you want to run the first script that we did on Monday by clicking on run and run all. But I don't think we have anyone new that wasn't here on Monday. So you should, once you have run the script, you should be able to see this yrbs.csv within your RStudio in your file pane. So today we're going to look at the Tidyverse collection and what it does. So like Alyssa said on Monday, Tidyverse is a huge collection of R packages specifically for data science purposes. So for manipulation, visualization, tidying, importing data, so on and so forth. I kind of like to think of it like a bookshelf and with loads of different types of books in your bookshelf. So dplyr is used for data manipulation, which is reshaping your data, changing the way your data looks like to make it ready for visualization. ggplot2 is used to then create really pretty charts. tidyr is used for data tidying, and readr is used for importing data and bringing in different data sets into your RStudio. Purrr, which is a fun name to say, is used for functional programming, and Tibble is used for creating modern data frames. So the first thing we're going to do to start today's workshop is load in the Tidyverse library, or turn on the library, as we have said a couple of times. So why don't we all try to turn on our Tidyverse library within our own project space? And you can let me know once you're done with that. Give you a
Actually,
quick
perhaps
minute. Yeah.
show them where to find the project just in case they forgot.
Oh,
Could you go back
yes.
to space? Yeah, just
Yes.
in
So yeah. So within your posit, you're gonna look at the 3 lines that pops up, and then click on Fair Forward. And then you're gonna click on Introduction to R Programming, and then this will open up your project space. Cool. So you want to turn on your Tidyverse library. So we're going to do this by calling in the library function and then typing in Tidyverse. So once you run that, your library should be all set up, and you can go in here into your packages and also click on Tidyverse. Scroll down all the way at the bottom. Cool. So after this, we're going to load our data from yesterday. So yesterday we brought in the YRBS dataset from CDC. We explored it. We looked at what it looked like and did a couple of exploration steps. And today we're going to store it and bring the CSV that we wrote in. So I'm going to go back to my files pane on the bottom right. And you notice that you see yrbs.csv. This is the file that we wrote yesterday at the very end of class. So to first do this, you're going to need to name the object. So we're going to call it YRBS. And then we are going to use the assignment operator, which is the left arrow and then a hyphen. And this is essentially going to store whatever you put on the right side of it into this new object called YRBS. So the function we're going to use is read underscore CSV. So you notice that as I typed read underscore, there's a bunch of other file formats that popped up. So you could also read in other types of files using the same function. So for now, we want CSV, and you want to type in yrbs.csv. So this is the call you need to bring in this data set. I'm going to run that chunk. And you'll notice that it populated within your environment on the top right. Another way to bring this in is by also clicking on the dataset and clicking on Import Dataset. And this is actually going to give you a preview of what the data looks like. You can take a scroll of the first couple of columns, the first couple of rows of what is inside this data, and it'll give you a code chunk on the right here that you can copy and paste into your R environment. So if you click on this little clipboard icon and click on import, you'll notice that it runs it in your environment. Close that and close this so we can look at our notebook. So now that we have the data set in our R environment, we can get started with the functions within Tidyverse. So the first thing we're going to do is look at the dplyr function. Like I said earlier, this is used for data wrangling, which is a very fancy way of saying data cleaning or data reshaping and manipulation. There are 6 very common functions that we use for this package. We use arrange, select, filter, mutate, summarize, and group by. So we're going to go through each of these functions in detail in a bit. But the picture that you see in your notebook gives you a visual representation of what each function does. So the first function, select, is going to let you choose different columns within your data set. So we saw yesterday that we had over 200 different variables, and you can also see that in your environment. If you look at the data, you see that you have 20,000 plus observations of 250 variables. So if we keep using this data set, it's going to use a lot of memory and computing power to create any calculations or any shaping. So what we're first going to do is extract columns that we want to look at. So we want to call in the object, which we named YRBS, and we're going to call it YRBS underscore select. And then we are going to use the select command. So inside select, you're going to call the name of the data set that you want to select from, and then add the columns that you specifically want to look at. So say we want to look at age. The next question you have is, so how do we know what the name of the column in the data set is? So to do this, before selecting, we can actually look at the different column names within YRBS. So if I run that line, you can see the different column names that exist within the data set. Yes. So.
Sorry, Padma, can you also just remind people how to convert from source to visual? Because they may, if they just open the notebook, it'll open in source, so it'll look different than what you're showing right now.
Yeah, so the first time you open your notebook, it's going to open within source here. And then you want to click on visual so that it gives you a neat notebook to work with. Hopefully that's pretty cool. So this gives you the name of the columns within the data set that you can now select. So when you use the select function, you can also choose to rename the column so that it looks a lot neater and easier to refer to. So in this data set, we have the survey question of how old are you? And that is essentially your age. So we're going to rename that as age equal to how old are you? And we're going to do this for a couple of different variables. So you have sex, which is what is your sex? You have grade, which is in what grade are you? You can also copy and paste this within your our environment. And then you can look at height, which is a survey question. How tall are you? You can look at weight, which is how much do you weigh? And you can look at sexual identity and mental health question, which is your current mental health. So if you run this code chunk, you will not see anything else pop up besides the column names because all we did so far is assign the object. So now you have to run the first couple of rows in this object, and this is going to be done by using the head function and typing in the name of the data object that we just created. So if you type in that, you can see that it pulls out the first 6 rows of this data set and the columns that we just selected, which are age, sex, grade, height, weight, sexual identity, and then if you scroll to the right, you can see negative mental health. So now we can take a closer look at how many students identify with each sexual identity category in the select object that we just created. So if we all want to now try using the count function that we did yesterday to count the number of times a different, yep.
So Padma, let's give everybody a chance to see if they can do it before we show them the answer.
Yeah, I was gonna say.
Remember that we used the count function on Monday, and you can always go to the help tab and type in count if you want to sort of refresh yourself on how to use this particular function. But in general, remember that usually the structure is name a function, in this case count, and then you've got your parentheses, which kind of opens your function, whatever data object name you're going to use it on, maybe some options. In this case, we want to use it specifically on sexual identity, and then close your parentheses. And go ahead and raise your hand if you've got it figured out, and give us a holler on the chat if you're stuck.
Within the help pane of RStudio, if you scroll down on the documentation, once you've looked up for count, it also gives you an example. I'm gonna scroll down a little bit to show you what the documentation looks like. Well, before I proceed to give the answer, do we have any questions from anyone? Is everyone able to load in the data set and make a project? Give it a second. Okay, we don't seem like we have questions. So to use the count function, what we would do is count in count function and select the data set that we want to look at. So YRBS select, and you'll notice that when I started typing out YRBS, since we are looking at the RStudio like environment, it does give you the options that you have within your environment. So you could also go in and select it that way. And then we want to specifically look at the sexual identity category. You run that, you can see the various counts of sexual identity categories within the data set. Do we have any questions? Was everyone able to get past or get through the step? I don't see any questions. Also, as a reminder from Monday, you can pop out the table into a new window, which I don't think you can see because it's not sharing my whole screen. But it pops out into a separate window. Cool. Alyssa, did we, oh, I think I see a question in the chat. You'll probably tell us later, but could you count and have it come out in a certain order? Largest to smallest, for example. Yes, that's a great question. We are going to come to it later in the workshop today. Great question. Yeah. Alyssa, do we want to do a very quick quiz or poll and take a pause
Sure.
on?
All right, why don't we go ahead and see if we remember some concepts from yesterday. Let's see if I can actually make this work. Oh no, I presented before I actually hit share. Hold, please. All right,
Sorry,
excellent.
can I ask a question?
Mhm.
Okay, so my question is, so what's the difference now between selecting just a column and then counting the sexual identity column, for instance? What's the difference between selecting the sexual identity column and counting like the sexual identity column? I don't know if you get my question.
Yeah, I think I understand your question. So when we use the select function specifically, it selects all the records or rows within that column. So when we did this function of YRBS select, we are collecting all of the rows and we're keeping the records. We're not calculating it. We're not doing any sort of summary. It is just the data set. And when you use the count function, this basically looks into the unique different variables within that column and then counts how many times it appears in the data set. So out of all the
Oh.
20,100 observations, you had 2,053 respondents that said their sexual identity was bisexual. Did that answer your
Yeah,
question?
thank you.
Okay.
Yeah, it does. Thank you.
Oh, wait, Alyssa, you're muted.
There we go. All right, you can either scan the QR code or you can also go to menti.com and then use the code 33881205. All right, this is just to help refresh us from some of the concepts that we covered on Monday. Oh, what? No, that's terrible. There we go. I wanted it to not be in the way of something. All right, we'll give this like 30 more seconds. Okay. Padma, do you want to go over this question?
Yes, so it looks like all of you got it correct. Essentially an operator is, yay, hurrah. An operator is used to assign everything to a specific object. This is usually used when you know you're going to come back to something and you want to keep referencing it. We don't have to keep, for example, just now when we read in the CSV and we assigned it to an object, we can just avoid reading in the CSV every time we want to do calculations.
All right, let's do, I think one more at least.
Yep. Do you think you can close out the QR code maybe?
Yeah, I'm just gonna
Since most people are in it. Yeah.
Hopefully we're in Menti now. You can always go back to Notebook 1 if you need a refresher on what our rules are around object names. All right, let's just give it like 30 more seconds and then we'll review this one. All right, excellent. Padma, you want to go over this one?
Yeah, cool. So I can go over why each option was wrong, and then I can recap the different naming conventions. So the first option, which is mouse space data, is incorrect because you cannot have spaces when naming an object. The second one is correct because it fulfills all the rules. It has underscores, it doesn't start with a number, it doesn't have spaces. The second one is incorrect because it starts with a number. Remember, you cannot start an object name with a number. The fourth one is incorrect
Wouldn't say it's
because
technically correct, it's
it's
just breaking the short.
bad practices. Yeah.
Yes.
Yeah, because if you could imagine naming this as an object, every time you call it, you're going to have to spell out drug treatment onto my strains with capital letter, like snake case every single time. So technically it is allowed, but just not best practices. And mice #2 is not allowed because it has a special character and a symbol. So overall, all the rules that I also pasted in the chat that we have on Monday's notebook as well is that the first character cannot be a number, it cannot contain spaces or special symbols. If you want to separate a word, you must use an underscore. And you can use a capital letter, but when your name is really long, please refrain from doing that so that it's easier to use. Names are very case sensitive, so if you call something mouse underscore data, you have to use all lowercase both times to make sure you're referencing the correct objects. Names should be unique and short, but understandable. You, like I said, you don't want to keep typing in very long names when you do all your coding and programming.
All right, I think maybe there's more that's useful. Yeah, we could do this one since we did cover this yesterday.
Yep.
Okay, I'm gonna go ahead and hit enter on this one. Maybe. There we go.
Cool. So I can also go over what each function does. Good job. Everyone got the right function. So yes, dim or dimensions for short, shows you the number of rows and columns within a data set. The function head, like we just looked at, gives you the first number, select number of rows within the data set. Summary essentially summarizes the different types of variables that you have in your data set, and SDR gives you the structure of the object that you're looking at. Cool.
Oh, actually, this is a good one to review too. Haha.
Yeah.
Oh, actually, I'm gonna put that Menti back up because somebody new did just join. So we are here. All right, give it like 15 more seconds. All right. I didn't trick any of you. I'm impressed. This one does trip people up sometimes. So well done.
Yeah.
What is
Good
the
job.
function? What's the function that turns on a package? You can shout it out or stick it in the chat.
Is it the library and then the Tidyverse?
Yes, that's correct.
All right. Oh, actually, this is a good one too. Yeah, we probably should have started with this. Sorry, everybody. And then while you guys are doing the poll, we can have the people who just showed up hopefully be able to catch up. All right, give this one like 15 more seconds. Oops. Huzzah!
Yay. Does someone want to try answering what would give us the number 11 directly in the notebook? Could throw it in chat or unmute.
Heyo!
Yes. Hey, that's correct.
Oh, we won't do that one yet, just kidding.
I've
Okay.
done that. Okay. Cool. I know we had a couple of folks join us as we were doing the Menti quizzes just now. So make sure you are all in to the project space. So once again, I will drop the link of the project link on the chat for anyone joining in for the first time. And you want to run your 01_intro.rmd notebook, and you'll be all set. So today we're looking at the second notebook. This is just a quick repetition for the handful that joined us late. If you want to click onto tidyverse.rmd, and you want to make sure that you have this CSV in your file pane before you get started. And if you don't, please let Alyssa know in the chat, and she can help you troubleshoot it. Cool. So we just went over the select function from dplyr or tidyverse. Second function we're going to look at is filter. The filter function lets you choose different rows. So remember, select, we looked at columns within the dataset, and filter is going to look at rows. And above, when we counted sexual identity, we see that one of the rows says, "Don't know what this means," as one of the responses. So we're going to use the filter function to remove these responses since we don't want to include them in our calculations. The filter function allows any logic operators. So you can have the AND symbol, which stands for AND, a straight slash, which is OR, a left arrow or lesser than symbol, a right arrow, which stands for greater than, an exclamation point, which is not, and this is usually used hand in hand with the equal sign. So for equal, make sure you use double equal signs and not one. And so anytime we want to change the original data object, it is a really good practice to create a new object so that we can go back to the raw data if we need to, and we want to look at the original data set. So now we're going to create a new data object, and this should already be done in your notebook. we're going to call it YRBS underscore filter. And we're going to use the assignment operator, which all of you got it correct last time in the quiz, is the left arrow and the hyphen. And we're going to use the filter function. So we're going to call in YRBS underscore select, which is the data set we just created above. And then we are going to filter out specifically sexual identity. And we want everyone that are not equal to don't know what this means. So we're going to use the exclamation point, which stands for not, and then we're going to use one equal sign. And then we're going to put in the response. So you should have this in your code chunk. If you want to run it, it's just going to run the object. And now you see that you have a new object in your environment, but it's not printing anything out yet. So once again, we can use the head function and call in YRBS underscore filter. So this will give you a preview of what the object we just created looks like. And we can also go back in and check. So if you want to now try running the count function again with the YRBS filter dataset, can you check if it removed it correctly? And if you want to raise your hand, once you've done that, while we wait, just to recall again, you can also type in a question mark and the word count. And this is also going to pop up the help section with the count function. it 30 more seconds. Cool. So we have the count function again, and we are going to run this on YRBS select. Not filter, not select. That's a good mistake because we want to look at the data set that we just filtered. And we want to run this on the sexual identity variable again. And you can see that that specific row that we removed, which is called don't know what this means, is no longer there. Cool. So we can also see that when we removed, when we counted the sex column in the data set, that there were missing values. So I'm going to type that in so that I can see what that looks like. So you can see that you have NAs and 111 counts for that. We could, again, use the filter function to remove this. The good thing about tidyverse is that you can use functions inside a function. So the is.na function gives you what is missing, and we want to do the opposite of it. So if we put in exclamation in front of is.na, it gives you all the values that are not na. So do we want to attempt and try running the filter function on the YRBS filter dataset and remove these values? Remember that we're specifically looking at the sex variable, and we want to remove what is not NAs.
Sorry, can you come again for the last part? Which one are we taking
Yeah.
out this time?
Yeah, so when we ran the count function on the sex variable, we can see that there's missing values. So you see the third row has NA, which basically means blank, has 111 records. So we want to remove this because we only want to look at rows that have records in them. So we're looking at the sex variable specifically.
Okay.
This is a slightly trickier question. So I'll start us off and then give you all another minute or two to look at it. So we're going to store it in this object, YRBS filter, and then put in the assignment operator, and then use the filter function again. So we're going to call in YRBS underscore filter. This gives you the filter dataset, and we want to specifically take out what is missing. So exclamation, which means not, and then you're going to have is.na, and then you're going to have the variable sex, which is the name of the column. You could also go into here, into your environment pane on the right and click on the triangle icon next to the name of the dataset. And if you expand this window, you'd be able to see the different column names within the dataset. So you can see that sex is the name of a column. And you want to run this line. And you can see that the number of observations have dropped now. And once again, we're not going to be able to look at this data set unless we explicitly call it out. So I'm going to type in YRBS filter, maybe put a head around it, and run that. And we can also double check this again by writing the count function. So this is going to be the same command as before. Nothing changes because the name of the column hasn't changed and the name of the data set has still stayed the same. So you can see that the missingness has now gone. It's only females and males, and both have 8,000 something records. I'm going to pause to see if anyone has questions. And if all of us understood how to use the filter function. So it's great. Okay, I don't think we're getting any more questions. For future reference, since we did run the filter function twice, Tidyverse actually lets you combine these conditions into one piece of line to make it one line of code to make it very neat. So one other way to do this is to call in both not NA with the sex variable and using the AND operator along with filtering out the sexual identity variable. So what this does is removes the rows that are not NA as well as the sexual identity column at the same time. So the AND operator lets you put two different conditions in the same line of code. Cool. So if you have any questions with the select or filter function that we've covered so far, please feel free to stop me and ask me or put it in the chat as well. Either way is fine. So the third function we're going to be looking at is the arrange function. So I think someone in the chat earlier asked if we can sort out rows in a specific order. And the answer is yes. So the arrange function lets you sort your data by one or more columns that are present in the data set. So let's say we're interested in looking at how tall the student is or how tall the tallest student is in this data set. We're going to use the arrange function. So you're going to put in a range and we're going to continue using the filtered version of the YRBS data set. And the arrange function by default sorts it in an ascending order, smallest to biggest, and we're going to want to look at it in the descending option. So we're going to use the descending function, which is DESC for short, and put in the height variable. So when you run this, you can see that in the first row, your tallest height is actually 2.03. This is really weird because 2.03 seems like a very short number for feet. So we're going to pause and look at the data dictionary to find out what units the dataset has used. So this is coming directly from the CDC website, from where the data was collected. And if you scroll down to the data edits, you can see that height and weight is defined here. And that you can see that height is actually in meters and not in feet. So we're going to want to convert this. So to convert your meters to feet, we're going to use another tidyverse function. But did the arrange function make sense? Do we have any more questions? on whether to sort it out by specific order before I proceed to mutate?
Sorry, can you just take the arrange one more time again?
Yeah, so the arrange function lets you sort out your data by one or more columns that you want to look at. So it arranges it by smallest to biggest value or biggest to smallest value. So by default, what it does is it goes from smallest to biggest. So if I just put in arrange YRBS filter, which is the name of the data set, and look at height, this will give you the smallest height in the entire data set, which is 1.32. But right now we're trying to find out who the tallest student is in the survey. So we used the function descending, or spelled DESC, around the variable height. So what it does is it takes the order and then flips it the other way. So it gives you the tallest person at the very top and the shortest person at the very bottom. So it arranges it, and you now have the tallest data set at the very top. Does that make a little more sense? Okay, okay, I see a thumbs up. Great. So now that we are all clear on using the arrange function, so far we've looked at select, which selects specific columns in your data set. We've looked at filter, which lets you choose within the rows in the data set. And then we've looked at arrange, which sorts out your data set based on a specific column. So the fourth thing we're going to do is mutate, which is basically creating new variables. And now we want to create the height in a unit that makes sense to us, which is in feet. So we want to use the mutate function on the YRBS filter object. So we're gonna, this code chunk should already be filled in for you. But just to demonstrate, we are going to first bring in the object name again, because we're trying to refresh the name of the object. And then we are going to use the assignment operator and then the mutate function. Within the mutate function, you're going to call in the data set you want to look at and the name of the new column. So we can call it height underscore feet so that we can easily identify that the new column is height in feet. And to convert height into feet, you're going to use the original measurement in meters and multiply this by 3.28084, which is the conversion. So if you do this by default, the column is just going to add at the very end of the data set, but we want to be able to compare it right next to the original height unit, which was in meters. So we're going to use the dot after function, an option, and put it right after height. And we are going to run this and print the data set. So when you run this chunk, you can see that height shows up, and right next to it, you have height in feet. Also next to height, you can see the weight variable, and you can see that the weight looks a little off. And if we go back into the same data dictionary, we can see that weight is in kilograms and not in pounds here. So we want to convert that as well. So the conversion rate, which we've given you in your notebook, is dividing all your weight value by 0.4536. So if we now want to try mutating or creating a new column in our data set and calling it weight underscore LBS or pounds, and try that out. You can refer to the code chunk right above this, and it gives you a skeleton of how it's going to look like. Very similar, you just want to do weight instead of height. And remember that R takes in all math operators and calculations, so you can use the plus sign, the subtracting or minus sign, an asterisk for multiplication, and a slash for division. Give it a few minutes. And you can raise your hand once you have it in.
Yeah, okay. She has open the car. Oh,
If you're feeling stuck anywhere or if you have a question midway, also feel free to let us know. Even as you try just for this question, we can help you out. Cool. So to do this, we would, again, we're refreshing the object, so you want to store it in the object again. So we're going to use YRBS filter. And we're going to mutate and use YRBS underscore filter, and then create a new column called weight underscore pounds or LBS, and take the old weight column and divide it by 0.4536. And if we run this data frame, we can see that the weight added all the way at the very end. And that's because we didn't use the dot after call within our mutate function. So if we want to go in and add the dot after, weight, see that it added. Cool. Do we have any questions so far? Are we feeling stuck at any point with the functions?
Yeah, I actually have a question. The
Mm.
the dots after weight and dots after height, what does it do exactly? That's the
Yeah,
part I didn't
so
get.
by default, sorry, did I interrupt you?
No, you did not. That's my question.
Okay. So by default, the mutate function, what it does is it adds a column at the very end of your data set. So even before we created all of this, for example, if we go into YRBS select, what it would do is put it at the very end of the list of columns. And when you say dot after equal to height, it puts it right after the height column. That's what it does.
Okay, cool. Thank you.
Cool. Questions? Not, we can move towards the fifth function, which is summarize. And this helps you create summary statistics within your data set. So far we've sorted it out by different order. We've created a new column. We've removed things that we didn't want to see in the data set anymore. But what if we wanted to do an additional calculation or use different functions? And this time, what if we wanted to look at average height instead? So we can use the summarize function and use it on YRBS filter, which is the filtered data set, and create a new column called mean height. Mean underscore height. This code chunk is also filled out in your notebook, but we're going to use the mean function and use the variable height underscore feet, which is the new variable we created when we converted our units. And we need to remember to remove NAs when we use the mean function so that it gets rid of missing values. So when you do that and you run the code chunk, you can see that the mean height is 5.56 feet in your data set. So you can also use the summarize function with other types of calculations. Like you can look at minimum, you can look at maximum, median, mode, so on and so forth. So remember that if you do have missing values, you can remove them by using na.rm equal to true. One way to check if you do have missing values is by using the count function. So if you put in count and YRBS filter, look at height, you can see it shows you all the values, and then at the very bottom, it gives you NA values, and you can see that about 1,000 rows have missing height data. So using NA basically removes this. Cool. So the last function for tidyverse. Before I do that, do we have any questions for summarize and summary and using functions within it? And yes, you can also look at the help pane. So one way to do it is typing the question mark like I did earlier, but you could also go in here in the search bar and type in summarize. And this will describe what the function does along with how to use it and different things you can pass it to it. Cool. So the group by function is actually one of my favorite functions in the entire Tidyverse package, because it helps you do some really cool things. So what it does is it takes your data set and groups it with by subgroups that you tell it to look at. So you can look at a column, for example, sex, and group by females and males. So let's see what happens when we do that. So you want to type in, by IRBS filter, and then the column or the variable we're looking at is sex. So if we run this code chunk, it doesn't actually look different. And you're looking at me like I lied to you about this being my favorite function, but that's because we haven't actually done any calculations. But you can see that when we ran this code chunk at the very top, it tells you that it has grouped by sex in the data set. So to actually look at what the magic of group by does is using it in combination with another function. So when we use it with summarize, it lets you do calculations or summary calculations within that group. For example, we can look at mean height within males versus females in the data set. So to do this, we are going to use something called pipe. So I like to think of this as like a noodle maker. You put in all the flour and then you kind of do like a turnstile wheel thing and it like pulls out the noodles for you. And that's essentially what the pipe function is. You're putting in something and you want it to continue moving it along. So first, we're going to take an object that we want to put in the noodle maker. And then we're going to use the pipe function, which is the percentage sign, the right arrow, and another percentage. So this lets you push things along and chain together different functions within Tidyverse. And once we have an object, we can select our next function. So first things first, we want to group by the sex variable or the sex column. And then you could pipe it again into the summarize function, because we want to compare the mean height between the two. So if you put in summarize and then repeat the call that we just did above, mean height. Sure, this is the one in feet. And NAs. If you run this code chunk, you can see that it gave you the statistics that calculated, but by the different groups that we had it. So we first group by sex. So it looks at the different unique responses within the sex column, so male and female, and then it looks at the average height between those two groups. Also notice that I have not stored this in the object, so it has not like added another column within this object in the dataset, and that I've only piped. So piping does not mean creating a new object or updating the object. You will have to specify the object in front of it with the assignment operator if you want to refresh the dataset. So now to get our hands on using the pipe and the group by function, how would you find the average weight for males versus females? You could once again raise your hand when you are done and done writing the code and running it, or you can unmute and ask questions if there's any way we could help you. Yes, so we have a question in the chat of what the na.rm at the end means. So by default, the mean function and a lot of other calculation functions in R does not remove any missingness in your dataset, and indicating na.rm essentially means removing na values or removing missing values. Lets you calculate the mean after getting rid of the missing data in the data set. So earlier in the exercise, at the very top of, or at the very beginning of the class and top of the notebook, we put in the count function and looked at whether there was missingness in the data set at all. And we first saw that there were about 158 rows that had missing data. So that's one way to check if you have missingness in your data set. Cool. So I am going to just show you how to modify our previous line to make it suitable to calculate average weight. I just copy pasted the above code line. We can call this mean weight instead of height. And we can delete the initial variable we were looking at, which was height underscore feet, and replace it with weight in pounds. And you want to keep this function for removing NAs because we want to make sure that we're only looking at numbers. So when you do that, it gives you the average weight between the two sexes in the data set. So the first thing we did was call in the data set we want to look at, and then we piped it into the group by function. So group by essentially separates your data sets internally and looks at the column that you want to group it by. And then we piped it into the summarize function, which then lets you put in any calculation functions. So we wanted to look specifically at the average weight for males versus females in the data set. And we removed any missing numbers or numbers that were not, that did not have any records in them. Before we continue, do we have any questions? We just went over the 6 major functions in tidyverse. So we looked at select, which lets you choose columns, filter, which lets you choose rows, arrange, which lets you sort out rows by a specific column. We looked at mutate, which is essentially creating a new column, summarize, which creates summary statistics for a specific column that you want to look at, Group by lets you group your different data for analysis purposes, and we also learned how to use pipes, which is to basically combine functions within Tidyverse itself. I'm gonna pause for a couple of minutes. I'm not seeing questions, so I'm gonna do a quick recap before we move into some problem questions for all of us to try. So once again, the select function chooses which columns you want to keep or remove. The filter function lets you choose specific rows based on the conditions you tell it to. So you can remove a specific type of value, you can remove missing data. Arrange lets you sort your data by one or more columns. Remember that the default is um, in ascending order. So if you want it to go from the biggest value to the smallest value, you have to use descending as a function inside your range function. Mutate lets you create a new column. Summarize calculates summary statistics, and grouping your data lets you do group-specific operations in math. Some useful tips are using the pipe operator, like we just looked at, to chain the functions together. And always use meaningful variable names. So if you just call it height2, for example, when we were converting it, it's not going to tell you what height2 means. So make sure you name it in a way that your brain remembers where to go back to. Commenting out in your code to explain anything complex. Using group by along with the summarize function lets you do a lot of powerful, cool analysis. And checking your data after each time you add a column or each time you do a transformation in your data set. So one quick way, like we did earlier, is to go within your environment pane on the right-hand side and just click on this little arrow that populates your columns down. And then you'll be able to see what you added and what got left out. So in the notebook, we have included some additional resources for you to go over if you want more explanation, clarity, and examples. So the dplyr documentation tells you how each function was built, along with very extensive examples and walkthroughs of how to use each function. The R for Data Science book is also a fantastic resource to go over examples and Tidyverse in much more detail. And we've also given you the link for the CDC YRBS website, and that lets you look over how the data was collected and lets you explore the data set in much more detail. Cool. So we're gonna pause and maybe do another fun, quick review quiz of the things we learned both on Monday and Wednesday. While Alyssa sets that up, if you have any questions or if you want to pause before we do the quiz.
All right, do you want me to go ahead?
Yes, all you.
Go. I'm just gonna tuck that over there. Oh, sorry. There, get my zoom out of the way. There we go. Okay, are you seeing the right thing? Hopefully.
Yes, we're seeing the right thing.
Excellent.
I have dropped the code for the Menti right now. And yes, the recording will be posted on our website in the next couple of days. So if you want to go back in there and take a look, it'll be there on our website.
All right, let's give it like another 15 seconds.
Cool. So yes, all of you got it correct. That is the select function. The filter function removes specific rows based on conditions. The mutate function adds another column. The arrange function sorts out your data set by specific column that you want to look at, one or more. Cool.
All right, give this one another 15 seconds.
Great. Everyone got that correct?
Next one. All right, I'm gonna give this 15 more seconds. Excellent.
Yay.
Right. Oh, whoops. I don't know why my I is missing. It's meant to say in.
The expression.
The expression. Let's give it 15 more seconds. Bum, ba, bum.
Yay.
And then I think this is one of our last ones. All right, let's give it 15 more seconds. Okay. Again, huzzah! And I think that's the end. It is. Huzzah!
Yay.
Okay.
Go back into looking at our problems. So if you want to go back and open up the notebook and navigate down to exercises, let's work on a couple of problems together. So the first question is, what if we were interested in the age of the oldest student that filled out this survey? You can use any of the above examples that we used in the notebook earlier today to replicate and modify the code. Looking at the environment pane on the right-hand side of your RStudio also lets you look at what each of your data set is named and what is inside each of them. If you want to go ahead and try the first question out and raise your hand so you have that in. to throw in a hint. So since we're looking at the oldest student, we are ordering it and we're comparing between a specific column. So when we want to order or rank something, we want to use the arrange function. Maybe a few more seconds. So within the arrange function, you want to type in the name of the object. So YRBS filter and look at the age variable. But if we do that, remember that the arrange function defaults into smallest to biggest. So we want to put in the descending function. Put in descending age and run the code chunk. You see that the oldest age is actually 18 years old. Cool. So the next question looks at specifically males versus females and how many of them filled out the survey by grade. So we're looking at two different groups and we were interested in what grade they were in. So if you want to try that, there's two different ways to do this. So we have a little or in your code chunk, but as long as you figure out one way to do it, if you want to attempt that and let us know again by raising your hand once you have that in. Remember when we wanted to compare between two different subgroups or groups in the data set, we used the group by function. And to look at the count or the number of records, we use the count function. Spoiled that one for myself. I'll throw yet another hint as we see more hands raising up. One of the ways to do it, the hint is that the count function takes more than one variable. So you can put in more than one variable with the count function. So one way to do this would be using the count function, like I said, and typing in the name of the objects we want to look at, the YRBS underscore filter. And then the first thing we want to count is the sex column, so males versus females. And then we're trying to count the number of records that are by grade. So count the name of the data set, sex as a column, and grade. So that way you're choosing more than one, and you can see that it splits it up into sex and different grade levels and how many people are in each of them in the survey. So that's one way to do it. Another way to do it using tidyverse would be to first call the data set out. So YRBS filter, and then we're going to use the pipe operator and use group by, because we're comparing between two subgroups, males versus females. We're going to group by sex, and then we're going to use the pipe operator again, and then we're going to use the count function and count it by grade, since we're interested in the number of students that filled out the survey. So this gives you the same output, and if you run the entire code chunk, you can see that it gives you both outputs, and you can compare, and they look exactly the same. Cool. So the third question is looking at the number of sexual identities of males versus females that answered they always felt negative mental health. So usually when a problem statement is really big, it helps if you break it down. So we want to look at the number of sexual identities, and then we're comparing it within a subgroup. But we are also looking at a specific condition within a variable. So to recap the different column names that we have, once again, I'm looking at the environment pane on the right-hand side, and I have the YRBS filter dataset opened up. You can see that we have negative mental health that we selected in the very beginning. And I spelled that wrong, but negative mental health. And you have sex as a column and variable to compare males versus females. And you have sexual underscore identity that gives you the sexual identity column. So if you want to go ahead and try attempting this question and giving it a shot. Let us know. Couple of tips are we are still counting the number. We are comparing between two different subgroups. And we are looking at a specific condition. So when you have any conditional observations or conditional methods, that's usually filtering because you're looking at specific rows and records. Remember that you can use pipes with multiple tidyverse functions. So just to get us started, also being conscious of the time that we have, we have YRBS filter as the data set, and then we want to pipe that into first the filter function, since we want a specific subset of the data based on this condition. So we want to call in the negative mental health column, and we want to look at always. Remember that you're going to need two equal signs when you look at the equal operator. I'm gonna give y'all a few more minutes to try to fill this other part of the question out. So now we've brought down the data set to this survey that just looks at always negative mental health. Now what we want to do is compare the count of the number in sexual identities for males versus females. So two more steps. Third step is going to be pretty similar to the step we did above. So since we're still comparing between males and females, we're going to group by sex. And we have one last step. So if you're still waiting to give this an attempt, now's the time. So we've done 3 out of 4 steps, and we have the very last step. We want to count the number of sexual identities in this piped down data set. Is it a minute or two? If you have the last step complete, please raise your hand so we know that you're able to follow and you have the code chunk complete. Awesome. So the very last step in this question is going to be using the count function again. And then we're going to bring in the sexual identity variable, then run the code chunk, and we're able to see that it's now spliced between the sex column, sexual identity, and gives you the counts just for those that answered that the negative mental health question as always. Cool. So this brings us to the end of our exercises for today. We have one last bonus question for you to try later, and you can feel free to text us more on Slack, in our Slack workspace that I also dropped the link on the chat earlier. Alyssa, was there anything else you wanted to add in the last couple of minutes?
No, just if anybody had any final questions before we wrap up. Otherwise, yeah, feel free to try out that bonus question, chat with each other on Slack about it if you get stuck, and we'll definitely also jump in if you want some help on that. Oh, actually, yes, just kidding, haha, I forgot. We do want to do the, we want to talk about how to export your projects, because right now these projects are on our training workspace, and eventually we will close that down because it costs money. So I did want to demo how you all can move it into your own free workspaces so you can have all of this content forever. So actually, Padma, I'm gonna have you do it since you've already got your window up. So if you could go ahead and click on the,
Oh, sorry, the project went to sleep.
it went to
happens.
sleep, it's very sleepy.
We're all a little tired. That was bad timing.
All right.
Okay.
It's like really, really trying. Where is it?
Okay.
Okay,
I was like, great.
So if you go ahead and if you want, you can actually just click on the like fair forward title in the top kind of corner. Yeah, click on that. Yep. And so this will bring you back to sort of like the workspace for the Fair Forward program. And you actually see like next to your project, there's a couple little icons. There's like a little plus icon, a trash icon, a little trolley icon, and a download icon. So I just want to flag two of these things. So if you do want to like download it onto your local machine and you really want to play with this and you've installed R locally, you can click on export and it will down the entire set of files that are in this workspace, sorry, this project onto your local machine. The other thing I highly recommend that you do is you go ahead and like that, there's that icon that literally looks like a moving cart. Click on that and it'll ask you where you want to move the space to. For most of you, there should really only be one option, which is literally your workspace. So click on that and then click OK. You'll notice that, first of all, it now says like start again for the project, and that's because you basically moved your copy. So then go ahead and go to the navigation sidebar and then click on your workspace. And you should now see all the work that you've done in your own space. So even after we eventually close this paid workspace, and even if the program is done, you will have this forever because there will always be a free Posit Cloud option.
Cool. We have one more minute if anyone has any questions.
Otherwise, once you've moved your project, you are free to head out. And thank you so much for joining us again today. And hopefully we'll see you later this month on Git information.